All right, folks, for those of us who are watching this to catch up on today's class, we are doing notes in class on day 4. We talked about how the last 3 days has been all about skills, and today is going to start real world. So far, we've just done this one part where we're going to make sure we know how to use our calculators to enter in these types of evaluating questions. So number 1 says to calculate m of 6, which means wherever I see x, I am plugging in 6. So this is going to be m of 6 equals 3 times 1.8. I'm using this as a guide. And now where I saw x, I substituted in 6. In green is what you're going to type into your calculator. So we're going to do 3, open parenthesis, 1.8, close it. And then this is called a caret. It means the exponent button on your calculator. If you're using one of the calculators that I signed out to you, you might have a button that looks like this instead. Find it. It's like a big empty box raised to a smaller empty box. That's the same as the caret. Those of you working on your phones, I'm going to keep running notes in purple. You might have x to the y on the phones. That's the exponent button on a phone. So people using a calculator, straight away you can just put this in all at once. What did you get as an answer? 102. Let's round to 3 decimal places. 102.036. We all agree on that? All right. Those of you using your phones, did you successfully get that far? All right, good. At any point, you let me know. For this next one, my phone people, you might have an extra step to do. Number 2, what are we substituting in? 55. So g of 55 equals 3 times 0.53. In this exponent position, I'm now going to write 0.1 times what? 55. Now here's where my people on phones, you might have an extra step to do. We'll see. In green, calculator people, 3, open parenthesis, 0.53, caret. I want to tell the calculator that this has to go together in the exponent position. So what do I need to make sure that I use right here to group this together? Parenthesis, good job. 0.1 times 55, close parenthesis and hit enter. People on the phones, depending on your phone, you might have to back this up a little bit and actually do this first. So if you're using a phone that doesn't let you see everything you type in, can you please do 0.1 times 55? Who's got 0.1 times 55? So this becomes 3 times 0.53 to the 5.5? Yes? Then you're going to do, watch the screen, people on your phone, do 0.53 to the 5.5 first, then multiply by 3. Yes, do 0.53 to the 5.5. Do that. Tell me what you get. Who's got that? Who's got 0.53 raised to the 5.5? I got 0.0. Let me see what you did. Let me see. 0.53 raised to the 5.5 should get us 0.0304. 0.0304, and then you'd multiply that. Do 3 times that, and what do you get? 3 times that? Yes. .091? Yeah. So my phone people, that's how you'd go about using your phones. This took 3 steps. People using the calculator, did you get 0.091 right away? Yes? Just checking in with you guys as well. So notice, the calculator is an essential tool. Between now and next class, please make sure you stop at Target, Walmart, anywhere. $12, between 12 and 15, you'll have that calculator you need from now till senior year through college. for most of us. Now that we're all squared away with how to use our calculators, let's start looking at a real-world scenario that deals with exponential functions. Can you raise your hand if you've heard of Chernobyl? I have 1 yes, 2 yeses, 3. Go ahead and read this situation. This happened in 1986. So if you ask your parents, do you remember what you were doing or how old were you when Chernobyl happened? They most likely will be able to tell you. Don't look at that. 3, parenthesis, 0.53, close it, and then a caret, right?
If you try like boxes over there.
Oh, because you have a caret. Other people don't.
Oh.
Right?
So wait, you just read equals? You just read equals?
Yeah, well, let me finish typing it in. So then in parentheses, you do 0.1 times 55. You're going to use that right there. Okay, do we all have a chance to read?
Yeah.
Yes. Let's grab our highlighters. I want to highlight the function, which is right here. From now on, as soon as we have a function, we're going to highlight it. And then this also tells me something about my variables. What do we know about variables here? Good. X years after 1986. So X is number of years after 1986. What does f of x represent? Good job. Amount of this cesium-137. That's this radioactive element we're talking about. Amount of cesium-137. And how is that being measured? What's the unit of measure for this? No, for the cesium. Kilograms. Yep. I'm actually going to move this over. We're going to do math here in a second, so make sure I kind of wrote this too much in the middle, so I'm going to move it over. Just make sure you have some space here for math. Hands up if you had a chance to finish reading. We need another minute? All right. 1 more minute to finish reading, and then we're going to talk about this situation. Before we do the math, I actually want you to see the effect of this event. In another class, one of my people in C period, his grandparents or parents, I forget what she said, were in Poland when this happened. This was considered an incredibly terrible, terrible event. And to show you why, we're actually going to watch a quick video about it. The music for this is a little creepy, but it's because it was a very scary event. Awful, right? So this happened in the Ukraine. Excuse me? So, what happened with the reindeer? They're contaminated. So any living body of any kind, when it's contaminated with radioactive material, dies or suffers from horrible deformities. You guys see what happened to his fingers? It's literally awful. So this happened in the Soviet Union, specifically in modern-day Ukraine. How far? What was the distance of the area affected? 19 miles. To give you an idea, guess how far it is from here to Buckland Hills Mall, to Manchester? 6 miles. It's only 6 miles from here to the Buckland Hills Mall. So imagine like 3 times that distance is the area that was affected. Not sure. You figure out what's 19 miles from here, and I'll add it for next year's notes. But just to give you an idea, right, from here to the mall, that's only 6 miles. 3 times that distance is the area that was affected. Did they think that they were going to be able to go back?
Probably not.
Well, they were told yes, right? So did they even take anything with them? No. So if you look up, like in Google, if you type in pictures of like Chernobyl today, you'll see these abandoned places. Like literally people just disappeared. They ran. Has anybody ever seen 60 Minutes? The show? They just did a program on this area in Chernobyl because did you notice the part in the video where it said people are still living there? Like roughly how many people are still living there? 200 people. And that's give or take that many. They're actually there taking care of their properties that have been abandoned. Specifically, a lot of them are cow farmers. And some of those cows did survive, but they're radioactive cows. You can't eat them. But they love them, right, because they were their livelihood. But what scientists are now studying is that those cows there are supposed to be all black, and they've actually got white spots all over them, which is a side effect of the radioactive environment. So scientists are now actually getting really interested in those cows because it's a living radioactive animal. So this is still affecting. If you nobody goes there. If you drive up to that area, it's illegal to live there. You can't live there. So the question is it going to be safe to live there in 2066? Let's figure it out. We have this model. That function is the actual exponential model. Is the actual exponential model that models cesium-137. All radioactive elements are modeled by exponential functions. So let's look at this one. Yes, that is the real equation that a scientist would use, that science uses for this situation. Now, we defined X to be the number of years after 1986. So if I want to know 2066, what would I have to do? Well, I'm not going to plug in 2066. How do I figure out that? How do I figure out how many subtract? There we go. So up here, let's do 2066 minus 1986, and you let me know what you get. (2066) minus 1986 is what? 80. So this is where f of 80 comes from. We have a model, yes? We all highlighted it? So let's use it. F of 80 equals, f of 80 equals 1,000 times 0.5 raised to the 0.03 times 80. People working on calculators, you are going to type in 1,000 all at once, 1,000 times 0.5 caret, and I need to group this together. So in parentheses, I'll type in 0.03 times 80. Remember, depending on your calculator, caret, Hold on. I'm sorry. Remember how I said we were going to do math over here? Sorry, guys. You can choose to not move it. I'm sorry. But I'm going to move it because I want to write a sentence down there. I got so excited about using the formula. I wasn't looking. I'm sorry. So remember, depending on your calculator, the caret button, caret could look like this, a box raised to a little box, X to a box, or X to the Y if you're on your phone. All of these mean the same as the caret. Let me know what you're getting as an answer. Who's got an answer? Mm-mm. So if we're using our phones, it's a little trickier. We should be getting something like 100 and, good job, 189 point what? 0.46? 464? What's the label for this? People on your phones, you do 0.03 times 80 first to get the new exponent, then do 0.5 raised to that number, then multiply by 1,000. You have to use your order of operations step by step. So f of 80 is 189.464 kilograms. So the question is, will people be able to live there in 2066? No. Why are you saying no? Yes, because what's the acceptable level? Nope, not 0. 100. So no, because levels of cesium 137 will not be below 100 kilograms. So think about that, guys. How old will you be in 2066? Even in that far away, people still can't live there safely. It's crazy. That's the power of radioactive elements and why exponential functions matter so much. You can all guess how old I'll be in 2066 at another day. Here is all a blast from the past, yes? We did this before. So what's A? What's A, guys? Nope, not 100. 1,000. What's B? Good job. Because B is 0.5, what kind of function is this? Decay. The reason is, since B is 0.5, that is between what two numbers?
0 and 1.
0 and 1. Very good. Where's my asymptote?
1.
0. Good job. Why is 0 correct?
Oh, because there's no K.
Yes. There is no K here, which really means I could just write plus 0. That's where K comes from. That's K. So let's graph. It should take us at this point 2.5 seconds to draw this graph correctly. I draw my asymptote on the y-axis. That's y equals 0. You said this is decay. So is the graph going to approach the asymptote or go away from it?
Going away.
Try again. Go towards. Left to right, it's getting smaller. And we're done. Go ahead and work on number 4. So number 4 is a much more cheery question. The prize for a radio station contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call. If they don't, the contest keeps going. Have you guys heard those on the radio? Right? Like, your name gets called, and if you don't call back in a certain amount of time. Oh, did I skip domain and range? Oh, no. Let's talk about domain and range. I come in from the left, I come in from the right. Do you see any restrictions? No. Good. Negative infinity to infinity. Or you could write all real numbers, total your choice. What's the range for this?
3.
Careful. 0. I come in from the bottom. This is going to get infinitely close to 0 but never touch. Come in from the top. And we're done. Awesome. Back to the radio. Very exciting. If they don't call back, then the radio keeps the card and the value increases by 2.5%. Ooh, what do I see that I should highlight? Highlight that equation. Make it stand out. And then as we're reading, if we see variables, we're going to underline them. This equation represents the amount of the gift card in dollars, T days with no winners. So if I know how to read for information, when it comes time to define the variables, all I have to do is correctly identify what I'm given. So this should be P of T, by the way. So T and P of T, what does T represent? Good job. Number of days with no winners. P of T equals what? Good job. Amount on the card. How are you going to figure out how much this card is worth in 10 days? Yes. Let's find that. Find P of 10. So that's going to be 100 times 1.025. And then instead of a T, what am I going to write? $10. Go for it. Find the value of the gift card. Use your calculators. Let me know what you get as an answer. Just to emphasize the calculator steps, it's going to be 100, parenthesis, 1.025, caret 10. What do we get? My phone people, well, those other, yes, good, that's right. My phone people do 1.025 to the 10 first. Let me know what that is. What do you guys get when you do 1.025 to the 10? 1.28, so then I write this, because 1.025 to the 10 is 1.28, and then multiply by 100. What do you get? Yes. My calculator people, what did you get as an answer? Or was it exactly 128? 008, so we'll round that to 01. So the gift card 10 days ago was worth how much? What was the initial value of the card? It was $100. 10 days later, now how much is it worth? 128. All right, let's go back to all of our awesome characteristics. You finish this all by yourself, and then we'll compare answers. Start to finish on your own, and then I will quietly work on it up here. If you have a question, you let me know. There was a good question on domain, on where we get negative infinity, infinity, all real numbers, whichever way you choose to write it. Watch the screen. Way back in Unit 1, for domain, we always come in from this side first. And what do you hit right away? An arrow. And I come in from the right, what do I hit? Arrow. So right away I know that that tells me this will be negative infinity to infinity. There is no restriction on the x values. The range, however, we definitely have a restriction. This graph will come infinitely close to 0 but never touch. If I come in from the top, what do you get? Yes. Which makes sense, right? If technically nobody ever calls in time, will anybody win the gift card? No, it's just going to keep more and more and more and more until somebody finally calls in on time. Done with number 4. Let's go for number 5, 100% by yourself. The only thing I'll help make sure we're on the same track with is that we highlight our function, our given equation right away, and then let's make sure we all agree on the variables as well. So when you have an idea for a variable, please let me know. I heard t days, so I'll underline that. That's good. By the way, this should say a of t. So t is days. I definitely agree with that. What about a of t? What about cubic inches do you know? What is that measuring? Good job. The air loss, and that is measured in cubic inches. So a of t represents amount of air left. The amount of air left in the pool, amount of air in cubic inches. So inches to the third is how we write cubic inches. Your task is to figure out what? Yes, let's do that. Figure out how much air is in the pool after 7 days. How much is left? When you have an answer to share, please let me know. Good question. The question was, do you need, for people on the phones, do you do 0.934 times 7? It's not times 7, it's raised to the 7. So you would do in your phone 0.934, whatever version of the caret button your phone has, 7. Get that number and then multiply by 4,500. Is there any decimals after that? 0.2. Good job. Are we matching in our answer? I'll come around. Those of you who get the same answer as me, start working on your graph. Let's do it together. So because you're on your phone, it's going to be 0.934. And then I hit this one, x to the y. 7. Enter. I take that number and multiply by 4,500. But once you have your calculator, you'd be done in one step. Who got 2790?
I didn't know.
Those of us who didn't, I'll come around in just a second. It's purely a matter of how you entered it. How many cubic inches of air did this pool have at the beginning? Yeah, 4,500. Just after 1 week, Look how far that pool has deflated. That's a lot. I don't know if I want some in that pool. All right, let's finish the skills side of it. You do it, I do it, we'll compare. Let's go for getting this done in about a minute. Remember, don't look up until you are done. Do we match? I'm hearing yeses. That's great. So we have roughly 10 minutes left of class. There are 4 practice questions on the next page that I would like you to try. 2 skills, 2 real world. We should definitely be able to accomplish these. Let me show you what they look like. I'll come back to this screen in a second. You have 2 skills questions and then 2 real world questions. This counts as in-class practice right now. You're going to work on this now. You can check with a neighbor or check with me. Tonight's homework is day 5 flipped notes. Day 5 flipped notes. And at the start of the video, I will cover these 4 questions as like a little video answer key just to make sure you're on the right track before you start your notes. So I will leave the screen frozen on this last question while you all can use this to check your work and get started on the class practice. Nice job today. If you had questions on your calculator, please let me know. I'll be around to help.